Bill, would you like to make your pitch?
Oh, yes.
So we have the mini conference coming up at December 16th here at the workshop. There are 10 papers being presented that day. Our format is that the paper authors don't present their paper. In Ostrom workshop format for the mini conference, your paper is presented by someone else who summarizes and critiques it, and then you have a chance to respond. So I have 8 papers assigned to presenters / discussants individuals. I have 2 papers that I don't yet have presenter discussants for. The working titles of those papers are up there. If you see one that you would be interested in, you will receive the paper on December 2nd, 2 weeks before the mini conference. You have time to read it, present it, critique it, and then the author has a few minutes to respond. So if either of those working titles up there catches your eye as something you would like to present on their behalf, that'd be great. Thanks. Just let me know.
Let's give everybody a 3-second chance to speak now. So, good afternoon. Welcome to the Colloquium, where for those of you who are warm and snuggly in a different place than us, we do understand today of all days. We've brought in today Tabrez, who's speaking on patenting deep learning, which his paper is posted. He's from California Western School of Law. He's also a visiting scholar here at Ostrom, however. And I mention that because I've started trying to do something a little different with the visiting scholars that I put forward, in that I bring them in for a short little welcome, here's what the individual's interested in, and then try for the second visit to bring them back for a longer period of time. We think that's working reasonably well. We'll see. But what that means is he'll be back for the bulk of April, and at that point in time would be looking to do more networking and expanding on this, and he's also going to be joining at least one of the working groups in the process as well, looking in these particular areas. So I'm not going to do an overview of the paper because you're better able to do that, but I'll turn it over, and I will of course keep the queue as usual.
Yeah. Great. Thanks for having me. Actually, really thank you for hosting and for all your efforts with me being here. And also thank you to the Ostrom Workshop and IU. It's been great being here. Also, as a huge basketball fan, I got to check out a IU basketball game this weekend, so that was a special treat. That was really exciting.
They actually won.
Yes.
The women's team killed, though. They doubled the scoring.
It was a closer game in the men's team.
Yeah, right.
But it was fun. Okay, so I'm glad to be here. It's my first time in the state of Indiana, too. I'm coming from California Western School of Law, where I'm an associate professor. I teach and write mostly in patent law, but broadly in IP and also entrepreneurship and also property law. So those are kind of my areas. I'm also a registered U.S. patent attorney, so I've kind of got some practical aspects to this paper and trying to make this interdisciplinary. As you saw, the paper's a bit early, so I've got an extended sort of intro, but there's more work that I'm doing on it, and we'll come back in April and have this further along. So we welcome your comments and questions, because I think that'll help me in adding to the paper, and also want to add some elements related to data science and engineering also. So I value the thoughts from that angle. So what this paper is about is a sort of new developing phenomena of deep learning and looking at it from the patent law context. And essentially the goal here is to try to look at promoting reliability and predictability from the patent law perspective of inventions in this area of AI, of artificial intelligence. So that's a high-level overview. And I'll start off by saying there's been a lot of buzz around AI, a lot of buzzwords being used around all sorts of parts of academia, and especially in law scholarship too. So what I'm trying to do is go a little bit deeper in legal scholar than what legal scholars have done recently into AI, and I focus on deep learning, which I contend is the more modern and where the direction of AI is going. And a lot of the legal scholarship on AI has been looking at effectively legacy type phenomena, as well as extremely futuristic type phenomena that may not happen. And so my goal with this is to look at incentives for patenting behavior with respect to this new and developing phenomena. And I think this is important from the standpoint of the sort of all the projections for AI. It's another type of transformational technology, and the question is, how can the patent system incentivize the level of innovation that's hopeful and aspired to achieve in this area? So that's the context to start off with. There's a lot of applications and uses of AI, and I'll start off with just sort of the patenting behavior. I have a few slides here. Various estimates show just this phenomena of very high patent activity. Right? So we see also patent races happening. Some of the fonts are a little bit smaller, but you can see here this sort of exponential rise that's happening in AI over the last 10, 15 years, particularly the last few years. There's been high growth rates. So some of this comes from an AI research group at Carnegie Mellon, and there's other slides that I have here of this data. So here's a subsequent slide, and you see specifically in machine learning very high patent activity. And the question is the patent system set up optimally? Is there some reform that should happen? And what are the doctrinal tensions with respect to patentability? Okay, and there's a lot of interest at very senior levels in government. In fact, President Trump has conveyed this national AI strategy in terms of R&D and also an executive order for competitiveness in sort of an international stage in AI. So there's been these recent activities, and many other countries, as on the right it shows, have also developed similar AI-specific initiatives. So this patenting aspect is critical to international issues and also important at the national stage. More recently, and where I focus on this paper, is what are the doctrinal challenges for patenting AI inventions? And on the left is a request for comments on patenting of AI from the U.S. Patent and Trademark Office, or USPTO, very recent in August. And on the right is something that actually last week I saw is the subsequent comments on AI innovation, which goes a little bit broader than the first one, which is on patent law on the left. And the one on right goes into other forms of IP, such as copyright and trademark. So the point from this slide is there's a lot of interest from the USPTO on how AI patents should be examined and what are some of the tensions with it. So this paper addresses some of those concerns that are very recent. So I look at this from the viewpoint of patentability, which for those of you not in patent law, this is the set of requirements needed to get a patent, the legal requirements to get a patent. And so it's like a funnel where you have several elements that need to be met: subject matter, utility, novelty, non-obviousness, and the specification. And so a quick high overview of patent law. It's you have to disclose how to make or use it to get the limited exclusivity, the quid pro quo of the patent system, and that's in the specification, but there's other requirements. And many of the tensions that legal scholars have talked about are with respect to these patentability requirements. The first one is subject matter, and the AI question has been, should AI be something that's eligible for patent protection? It is arguably abstract, or is it an application of abstract principles? Utility hasn't generally been a problem, neither has novelty. Non-obviousness has been talked about quite a bit. This is with respect to more than one reference when combined, would it be obvious to a person having ordinary skill in the art? And that standard with respect to AI is complicated because we're no longer arguably talking about a person, but something that's perhaps more superhuman-esque. And so there's been some discussion on effectively superhuman type machines or thinking machines, and whether that standard is something that has it still works in the AI world. And then specification, which is part of where I focus on in this paper, is enough disclosure being given in a patent application. And there's some theoretical concepts with it, particularly with respect to theories of the patent system, economic theories of the patent system, such as disclosure theory, commercialization theory, prospect theory, and the reward or incentive theory. These are all theories that tie into how much disclosure there should be and what are the effects of it from an economic sense. So I'm focused on that. So that's kind of some background, and this paper, as I mentioned, focuses on, sort of pun intended, deeply on deep learning. So it is a subset of AI, and most of the scholarship in this area in the legal realm has really been about machine learning, and I focus on deep learning. And the points that I have here are, this is the black box that scholars are talking about that enables automatic insights from unstructured data and has hierarchical elements to it. And so with the increase in compute power, better algorithms, and availability of data, we're moving into this deep learning realm. And on the graph on the right, you'll see that this is sort of the more newer aspects of it. And what I'll focus on is the method patent claim, which you see on the y-axis there. So the challenge here is, how does one claim deep learning algorithms? And a quick overview of this. This is kind of machine learning in general, and the doctrinal tension I'm focused on is the trained set, which is here. So as a high-level overview with machine learning, you have data, there's some sort of model that's built by recognizing patterns in data, there's the built model, and when there's new data added, it can make predictions. And this is the tension that I bring up. The narrow focus of the paper is how to capture this in a patent context. Now, the natural reaction could be that, well, rather than pursuing property rights in patents, one can pursue trade secrecy, and that is definitely an option. And there's also a phenomena of data generating patents that others have talked about, which is patents where there's value in the data itself, and some of it could be captured in patent, and some of it could be pursued in trade secrecy. But as far as the patenting behavior, what I'm interested and focused on is how it can be captured, and we can set up an incentive system with clear boundaries to incentivize innovators. And on top of that, there is very high level patent activity in this realm. Many of those patents are really not that strong. They're weak, and this set of sort of prescriptions that I have later, I think, will strengthen patent rights in AI. So the claim I make is that there's tremendous challenges for patentability of deep learning inventions. And it stems from the technological phenomena itself, which I say is inextricably linked to the legal frameworks here with patentability. And so what's the tension in this? The tension with deep learning, which is where the state of the art is right now in AI, is that there's many hidden layers. And this is what complicates things with respect to patent eligibility and also the specification aspect of it that I'm focused on. So the thesis is that there's this inherent dynamic nature of deep learning, or what I call dynamicism in patent law. So this is the tensions that are caused with a claim format that is not easily captured by patent law, particularly the method patent claim. So dynamicism, as I just mentioned, it's in the deep learning sense, as I define it, is that an invention does not exist physically until and unless it's fed with new data. In other words, I claim that this is not in the four corners of the patent itself. And the reason for that is that the manifestation of the invention happens later. It happens in a trained state. And this goes beyond the gerund steps of a method patent. These are refers to the ing verbs that are used in patent law for method claims. And this is a sort of a historical artifact of patent law, which really developed 1800s, 1900s, where this was based on the physical realm. And I claim here we have a temporal component with this dynamicism phenomena that I've identified. Okay, so method patent claims, and I'll go through this very quickly. Method patent claims here you have on the left one from a law professor that's done quite a bit of papers in method patent claims, but it's a very simple example of a swing. You see the verbs on the left, although maybe a bit hard to see, but they're ing words. And you see that in the swing, a simple example, there's some inherent intangible aspect of it, right? It's not capturing in the method claim the actual swing itself, the product. But there's an inherent intangible aspect to suspending, positioning, having, and then repeating the steps. In the deep learning realm, on this figure right here, you see a trained model, and although inventors are attempting to capture this with ing verbs, the real use of deep learning models are when the model is trained and then fed with new data. And this, I claim, is hard to capture, and that's where the doctrinal tension comes in. So what are the tensions with this? The tensions are that deep learning focuses on correlative statistics, not causal steps, meaning not from step 1 to step 2, but more on the correlative statistics part of it. The model itself changes with new data being fed in. So we have a tension here with the ing verbs being used in method claims, and the past tense when something is trained with an ed. There's also multiple layers between the inputs and input and the outputs in deep learning models. So these are the doctrinal tensions. And to make this more practical, as I mentioned, you're not going from step 1 to step 2. The gerund format of method patent claims, as I mentioned here, is not applicable. And arguably, there's not possession of the invention. Possession is a concept in patent law that says the invention needs to be within the written description, the 4 corners of the patent document. So the prescriptions I have and where I think patent law should evolve here is we need to get past the ing verbs with method patent claims and have a past tense format. And so I have this proposal of using something akin to what is called a product by process claim, which is used a lot in the material sciences and other forms of chemistry and unpredictable arts. It's practically speaking, in practical patent law terms, it's usually one claim that shows up at the end of a set of claims. And I say this would be a similar analogous format to have for AI. The second is genus-species equivalent. So when you have a species, it could anticipate a genus claim in patent law. And taking a step back, this refers to, as an analogy, a genus could be fruit, a species could be apple, a type of fruit. And so what is going on in this phenomena of deep learning is you have some set of blocking patents when parties are claiming too broadly. And so I'm trying to make this a little bit more stronger of patent rights with respect to these prescriptions that I have. And the last thing is I would recommend the USPTO have greater disclosure of the interplay between the input black box and output. So a little bit more strengthening of what's needed to achieve the specification. To wrap up, and I know this is we'll have more discussion in Q&A, what this does from a theoretical sense is make it that the inventor and the patent attorney or patent agent spend a bit more time in pre-filing activities. So this has some effects on competition and innovation. And I draw on one of the theories of the patent system prospect theory, which is more focused on broad patent rights and after granting of the patent, the derivative inventions. And there's some effects on the interplay between monopolistic aspects and competition. And basically, I say what this set of prescriptions that I have does is strengthen and tighten and make more clear patent rights with respect to deep learning. And it fits in well with this modified prospect theory that economists have come up with much more recently. So I'll stop there. There's more to this, but I want to be careful of time, and happy to take questions and thoughts, and we'll have some this paper further along when I come back in April.
Questions? Cool.
Yeah, I can go first.
Yeah.
Someone else. So what's still confusing me is what type of things that people, like, you can look at deep learning from different perspectives, right? There is the technicality, there is a techniques that you use to learn. It can be like the threshold function, for example, something more foundational. That there's the layer of it, how you arrange the layer, and or I think they call it architecture, and then there's the parameters, things that you learn, and then there's the output. Which one is it that people want to patent, and like what type of applications? I'm trying to concretize the kind of scenario that these needs to be patented.
Okay, yeah, good question. So there's obviously many things that can be claimed. So you mentioned a few. I think the method, the algorithm, the how to arrange layers, parameters, or the output itself.
Yeah, right.
What I'm focused on is the claiming of the training step and formation of the trained model, and how to claim that when knowing after the fact that the trained model could be used in a variety of ways. And the tension goes with using the ing verbs in a method claim. That does not encompass the trained step. So that's really what I'm focused on. It's a little bit narrow. But the patent law historical perspective is that it's much more tied to physical principles. If I'm making something, like we have these cookies here, you're assembling a set of ingredients going from state 1 to state 2. Here, what is going on is you may have a series of states later on that result based on what the trained model is.
Okay. I'm trying to understand how is it different from simpler statistical learning, like linear regression has been used since forever. What makes it more complicated than that?
Good question. Yeah, so on that, the question in regards with linear regressions and even could be probably other types of things, linear algebra and other things like that, right? Decision trees. There's an area of deep learning that's still being studied in terms of what happens, stuff that's unstructured. And if there's other engineering folks here, I would welcome some additional thoughts on this too. But the tension is that it's unpredictable. That's one aspect of it. And there could be different outputs based on what data is fed into the trained model. From the patent law side, what I'm concerned about is what is the best way to claim this, and the general way of using method claims, I argue, is not very clear.
So I'm still trying to, sorry if anyone was,
Yeah.
I just wanted to follow this up. So I'm trying to distinguish the difference between more basic statistical learning and deep learning. So you're referring to like the complexity of the unpredictability, but isn't that the case for statistical learning as well? Like with linear regression, with different data, you have different model, different parameters, different input, you have different outputs. So what's different about that? Or maybe statistical learning is also difficult to patent as well. Is that also the case?
That's a good point, right? So both of them are effectively correlations, right? You're getting one thing versus based on certain trends, getting some sort of output prediction, I think is what you're doing. So that's a good question. There's a few things with it. One is with respect to just the amount of horsepower that you have with deep learning, right? But this is something I need to go into a little bit more. I think it's a good sort of counter argument is like, what is really the difference that you have? It's a greater scale is one aspect of it. And I think from the incentive side is if you have something with such a greater scale and you're blocking others from doing something similar or making improvements on it, rather, it could have bad economic effects.
So
That's a
what?
good question.
Oh, hold on.
Yeah.
We'll come back.
So I also have several questions, but I'll just leave one for now. But so I have dabbled in kind of machine learning and computational text analysis, both in the structured and also unstructured. So when I think of like structured, I think of like kind of computer-assisted content analysis, where you give it a corpus, you train it, and then it goes and reads another corpus and kind of tells you stuff. Whereas the unstructured really just reads it on its own without any training in advance. Both of those seem to be of the same, use the kingdom, phylum, order, genus, species type of claim, right? But both of those seem to be of the same order, but different species, one being structured and one being unstructured. So in this, I mean, in the graphic, you do have this kind of, this step one of, at first it is, you train it and then it does something, but a very similar type of deep learning, you don't train it, you just kind of unleash the beast, right? And it goes after the corpus, or it goes after the data. So would you also consider this in there, in kind of the updating to kind of, you know, patent law and that process, or is there something about that initial step that's kind of critical for this project that you're working on?
Okay, good question on that too. So the part you're mentioning is with respect to whether when there's not training, right?
Yeah, I know it as unstructured, yeah.
Okay, yeah, so I'm really focused on the initial part of this, with is just looking at various patent claims on this, which is that when models are captured, that's really the things that are being captured itself in a method claim. That's what I'm focused on, and the fact that once it's trained, it achieves effectively a new state.
Right. Do you think that's a different in order, or do you think that's a different in species? Are these different concepts, or are these just two different subtypes of the same concept?
So, okay, to clarify that, yeah, that is what is more of a genus. So when there's broad claiming of the model itself as a genus, so this is, again, the analogous aspect of this is in to chemistry in patent law, where you have some sort of chemical structure, and the broad claim is the genus, and the species or some subset of it.
Yeah.
This is the analogous in machine learning, and what I'm saying is that the model itself, that can be, when there's new data fed in and can be trained, then you have subsequent species of it. So the steps that form the model are the genus in the way I'm looking at this.
Okay. Okay.
There's, and the lesson from this is that there's things we can learn that are based on cases from the, what's called the unpredictable arts, chemistry and the like, that we can apply here to machine learning side.
Yeah, okay.
Got me thinking about a few things.
Yeah, that's interesting.
Did you have a question? Can you put up the slide that was the neural network? So if I was this one.
Yeah.
So if I was thinking about explaining this to a group of people who don't, who only know the basics, can you show me where you're talking about what stage up here the patent would be preventing others from replicating?
Yeah, okay, good question. So this is a little bit more complicated, but I'm really at the, go to another
Yeah, so if there's another slide, sorry.
So I think this one, the one on the left, that's immediately to the right of the dotted line. So this is the final machine learning model right here with this initial data set here.
Right.
So this series of steps could be captured in an ing.
Right.
That's what's being done. So what I'm worried about is what happens after the model is trained. So that's the aspect that I'm worried about.
Okay, so
the unpredictability comes with after this step is done.
So you want to extend patents to cover the final created as opposed to learning portion of the model.
Correct.
But are models linear? Doesn't this presuppose that there's no feedback occurring to the next? Otherwise, don't I have to keep updating my patent?
Yes, that's the tension, and what I'm focused on is on the claiming aspect of it. How best can I claim this in one of the statutory formats of it? And so that's exactly it, is that there's something, you can capture this aspect in a series of linear steps. That's effectively what a method claim does, is capture it in a series of steps. Mm-hmm. But what happens after that aspect, that's where the nonlinear or unpredictable aspects can come in after the model is trained.
So your concern, if I'm somebody who does this, what I wouldn't be able to do, because right now I can capture in the method or the process in which I create the model.
Mhm.
I can patent the process in creating the model, but I have very little protections when I actually put the model into the wild and everyone can reverse engineer or whatever and now replicate the model.
That's the starting point of where I'm at. Essentially, the value itself is the after effect. That's what is valuable.
Right.
The starting point in getting to the trained model can be captured through a set of steps in a process plane, but the more valuable aspect of it is after. That is which is difficult, and that's also dependent on the training set of steps itself, the initial part. So there's a dependency between the two.
Mm-hmm. And you would like us to, I'm just double checking I understand, and you would like us to appreciate the fact that the value that patent law has always tried to give back to the original inventor really resides in the end in the model.
Yes, so as an analogy, again, going back to the cookies, which were great, you have, once the cookie is formed through the series of steps, that is the value, right? There's
Yeah.
something that cookie achieves at the very end. It's not going to do other things after that fact.
Yeah.
So I'm trying to give clear incentives and predictability to inventors with how to capture the more valuable aspect after that, after the trained
Mhm.
step.
Is there a downside to that?
Yeah,
I'm
so,
taking a prerogative, sorry.
right.
I'm having and then I promise.
The downside is you
And then
have,
what's the downside?
right, so you have more, couple things going on. So if I'm first it's very difficult to make a massive change in patent law, right? So if I have a different claim format, it's just hard, may need some legislative aspects to get this achieved. The other part of it is if, besides the transformational sort of change it could be, is there something unique about this technology versus anything else? And
Right.
is this only a sort of a limited time aspect? There's been certain technological specific aspects to patent law in terms of even this product by process claim, which is specific to the unpredictable arts. There's methods of medical treatment or another, but every time you carve out something that's specific to a type of technological area, it's sometimes difficult to identify if something qualifies for that.
Mm-hmm.
Well, so and you also mentioned on the top of page 7, but you mentioned in your talk as well about, you could do a trade secret or you could patent. Why would one choose a patent over trade secrets? Can you not monetize either? And this is maybe just kind of I'm not trained on this stuff.
Right.
But if it's that complicated, why not just do the trade secret?
Yeah, and that's where arguably a lot of the phenomena is. Now, there's different perspectives on this where people lean in terms of the value of one or the other. So those that feel patents are valuable will say, hey, there should be stronger rights for it. And some others that will say, we should not have this in terms of, for example, anything that's software or business method-esque. The benefits that I argue for this are with respect to disclosure, and there's been some empirical studies on this in that when you have greater disclosure, it tends to affect economic activity in terms of those that read from it and start making improvements on it. So if you look at past technological phenomena that develop rapidly, that it's helped spawn other activity later on. So it's based on the disclosure theory perspective of patent law.
Okay.
So as it relates to deep learning, if it's not clear to others in this field how something is being done, yet they're given a patent grant, or they have chosen trade secrecy and it's not disclosed therefore, it makes it harder for follow-on innovation.
Right. So for the individual, it doesn't really matter, but for like society or for the future.
Yeah, a broader societal welfare perspective.
Right. So that's why we want to make patent law as good as possible, so everyone chooses that.
That's one
Right.
perspective.
Yeah.
You may have others arguing the other way.
Yeah, okay.
Mhm.
Thank you.
All of us non-experts in the room are trying out our different analogies. So here's an analogy tryout. In what ways is this similar to, and what ways is this different from trying to patent the chain reaction that occurs after a catalyst has been applied to a combination of elements or compounds? Like I could combine things and then in a certain way, and maybe I could patent that. I could seed the reaction with some sort of catalyst, and maybe I could patent that process too. And then once that's all happened, then this thing that in certain respects I've created, in other respects happens sort of beyond my control, occurs. To what extent is patenting deep learning in the way that you've described it, like trying to patent the chain reaction that happens after everything that led up to the chain reaction?
That's a good question. I haven't thought about it. I need to think a little bit more about this. So, for disclosure in catalysts, which are chemical, physical aspects of it, you need to give something about generally the structure, function, and properties of it. Something physical or chemical, so it has some sort of thing you can see in the physical world. So one would have to have some aspect of it, whether it's some temperature or concentration.
Which is like patenting everything in that.
Right.
In that string of arrowed boxes until you get to the last box.
Right.
But you're talking about patenting what's in the last box.
That's right. And what are the after effects of it if it can't be predicted, which is similar to the chain reaction or the catalyst. So I need to look a little bit more into that. That's a good thought on it, because it has some.
I don't know if it's even ever been done or attempted.
The in terms of catalyst.
Well, catalyst.
Catalyst,
certainly. Yeah. But this sounds like it's one step beyond that. Like I'm not trying to patent the catalyst. I'm trying to patent what happens after the catalyst.
When you think of this in your own head, what example do you go to? Do you go to like a computer software? Do you go to like driverless cars? Do you go to like, like what is it your concrete example?
Well, there's I should have that. I think that would be a good addition, is to go through some aspects of it. This is typically used in image processing, so including with autonomous vehicles and other aspects of it. Also, healthcare imaging. There's other examples where a lot of it's used with imaging. You have some sort of image, and then it does feature extraction, shape extraction, and says exactly what it is. A common example would be showing faces of, presidents, US presidents and others, and saying, identify who this is, and you don't see the entire image of it. And through a series of steps, it can tell what it is. Various other applications, going around and taking photos on my phone. It's somehow knows that I'm at a certain specific IU building based on the millions of other photos taken of similar people.
Would the patent then allow the patent holder to privatize all the efficiencies of like driverless cars? Is that kind of what that patent would do? Like be able is that kind of what is that the goal?
The end goal is just having greater disclosure for follow-on innovators. So I'm very much focused on disclosure theory and the benefits of that. If I'm a inventor or entrepreneur innovator in the space and I want to improve upon this and sort of at a macro level, if the goal of AI is to get to a general purpose AI, this is one aspect of it, which is what are the incentives we should provide to innovators on that. And it's to teach the subsequent innovators in this.
Yeah, so I'm still trying to understand or concretize what is it that the patent law would be protecting. So let me put it this way. Let's say I have trained a model. So that involves the data set that I have, the structure of the neural network, the parameters and possibly some output that I try out or some output that I get from my private data. And let's say I'm another engineer there's another engineer who comes and look at everything. And with all this knowledge, I can do a lot of things, right? I can take your model and train with new data,
Right.
get a different model with the same structure. I can look at your parameters and your model and then take the entire thing and use it for my own benefit.
Right.
Which part of it that you want the patent law to prevent?
Okay, yeah, good question. Let me clarify this. So what I'm looking at is the party that has trained the model, do they have rights to the after effects of the trained model? Because you will have those subsequent parties using others using the trained model in similar to the hypothetical escape. That's what I'm focused on. I should have clarified this better.
Okay.
That's a good question. Helps me frame this a bit better.
So, is it possible then? So let me switch back to like the more simpler model, like regression. Right? With regression, it's simple. It may be obvious in many ways because you can look at the parameters, and then you can first of all reason about what this means. Second of all, you maybe, and I don't know if this is the same process or not, but you can put down all that parameters in your patent. It might not be a method. I don't know anything about patent law.
Right.
So, but what you might be able to do is that you take all that numbers and then put it in your pen and say that no one should be able to replicate this. Can you do that the same thing with machine learning, where you take like millions of parameters and put it in a file somewhere and say that no one else should be able to replicate this thing that I came up with using my data?
Yeah, so I'll give, it's really the short answer is the scale of things. And the second short answer is that with regression and other sort of more simpler methods, you can identify certain physical aspects of it much easier versus here, it's much more grander scale and a lot more things going on. I'll tie it back to my own patent as an inventor going way back in 2004. So without going into too much details of it, it was finite element methods, and it's somewhat similar to regression. It's a different math kind of thing in general, but basically I was part of a research group that invented a device used for signage applications and figured out how layers of the material should go together. But it was analogous to a sandwich. You have different layers put together and it performs in a certain way. What I was able to do using finite element methods and finite element analysis is figure out properties of the whole device and temperatures and other mechanical degradation type things of the various layers. I could capture that in a patent claim because one, it's linear in terms of it was fairly simple compared to present day. One layer affects another, affects the entire device. The other part of it is that I could figure out properties that were physical. Okay? With regressions, you can still have certain, it's much more simpler and you can also tie it into things you can track. The difference here is the scale of things. Imagine the sandwich, but it's 100 million sandwiches, right, with different layers of it.
Yeah.
So it's really a scale difference when you compare to regression.
I still want to understand like the physical, because I'm not sure what that means exactly.
Sure.
Scale I understand, but
Yeah.
physical, what does that mean?
So even going back to my example, I should have had this on the PowerPoint, I could show it a little bit better, but imagine a sandwich. I think we're about to have sandwiches, right? So imagine a sandwich. You have, cheese, tomato, whatever, and I'm starting to get hungry also, by the way. It'll have certain things you can track with it. So for example, might have a melting temperature. It might have a texture. When it melts, it becomes softer, I guess, is one aspect of it. You can, even if you were able to use some sort of mathematical methods to predict how the sandwich could perform in a certain temperature, you put it in an oven, it could have a certain temperature. The lettuce might deform more than the something else, the onion, because the onion's harder. You can figure out parameters in the physical world of those layers and then claim it in a mathematical format. And you would have, the main thing is you would have enough of the physical world you can put in your specification, which is the quid pro quo. describe to us how to make or use it. You're effectively describing some aspects of the making. That goes back to also the catalyst example, where there's still some concentration, some physical aspects of it you can put down into it, even though it may be have some unpredictability. There's still something you can put down on it and get the section 112 or the specification requirement of patentability met.
So, just the last.
Your questions are helpful though. I think talking about comparisons to regression and then that's helpful. So I'm gonna follow up on that.
What I'm getting from what you said is it is a sensibility of what you're patenting. Is that right? With regression, with regression, you can say that if I feed in this type of data, this is the kind of thing that I'm getting out. And is that what you're saying, or?
The correlative statistics are much more on a grander scale than regression.
Right. Oh no, I'm just trying to get at what you mean by physical. Like when you apply it to linear regression. So the physical would be that you can kind of explain the property of this lead model.
Right. You can explain properties when you have fewer variables.
Right. Okay. Gotcha.
Yeah.
So if in a sense a machine learning model can be explained in the same way, in a less complex way, then it may be possible to patent that. Is that?
That's a good
right?
point, right? If it's less complex, yes, it's easier to do that. I'm at the greater complexity, greater scale aspect.
Okay.
But you're saying if you get to, so I should probably make a diagram of basic statistics to really complex ones,
Right.
and tie that into the spectrum that I'm looking at in terms for patent.
Right.
So that's a good thought.
And as cheesy as it is, I gotta tell you, I get the sandwich when you say it right away.
Yeah.
As weird as that is, of course, the lettuce too cold.
Pun
When
intended on
when-
cheese.
Yeah. But when the lettuce is too cold and you drop the warm cheese on top, of course, everything gets mushy. I mean, it does. Whoever's gotten, the hamburger right, the Big Mac or whatever right, who's figured out how to cold to keep the lettuce, how warm to keep different things, without it becoming one mushy lump of glub. Yeah, that makes complete sense.
I need to think of more
It might be a
analogies for
little
this.
too simple for the paper, I get, but
Right.
I think it makes it very, or the catalytic reaction,
Right.
I thought worked really well as well. I'm like, oh, of course, there's gonna be so much concentration of these different things at these particular temperatures and things. Scott had a question. Go ahead.
Yeah. No, it's pretty brief. One, did you already know Mike Manioli here?
Yeah, we've exchanged emails.
Okay.
He may be listening on.
Okay,
Hi,
good.
Yeah.
Obviously, because there's a lot of overlap and interest.
Yes.
He's
Yeah.
a great guy, and if you guys
Yeah.
haven't had a chance already, I think you'd have some
Should
great
talk to
insights here. Yes,
Yes.
for sure. And then so two. We've been working on a governing AI paper a little bit. This is the thing we presented in China last weekend, and it's up on SSRN. And for what it's worth, I don't know how much you're going to globalize any of the discussion here, but if you wanted to bring in some of the IP protections, especially in the EU or China or kind of some of the other AI superpowers, it could be interesting. If you want to take it in a more public policy direction, kind of echoing Tony's comment about the benefits of trade secrets versus patents here, I'm wondering if you find at the end of this analysis that maybe the patent regime just isn't that well suited to particular kinds of deep learning. Or neural networks, could you leverage, for example, the Beijing AI principles and some of the overlap that's going on there with the EU approach? And would that be a way to protect, some other, or to help crystallize some norms at least around, protection of some of these other related areas? Again, it might be too far afield, but if any of this paper particularly takes kind of an Ostrom angle at looking at that problem, and we did autonomous vehicles as the case study. So if it would be helpful, it's just governing AI. It's up on SSR, and then I can send you the link to it.
I'll take a look at it. It's very
helpful.
I'm looking at more from the doctrinal tension of method patent claims and trying to capture this, but the broader policy view is really a lot of the AI-specific patent law interest in the U.S. is, I think, in response to China AI patenting behavior. And what's happened practically here in the U.S. is that it was very hard to get these AI patents earlier because of patent eligibility, saying basically we have abstract principles. How is this actually different from abstract principles?
Yeah.
So the pendulum's actually swung the other way. It's fairly easy to now get AI patents, at least through the patent eligibility hoop. And part of it is the revised guidance now has these what are called enumerated categories.
Yeah.
And essentially, if you can show that it is not an abstract principle, then you can get it. In other words, there's been loosening of this in letting these patents through, and it may be that this is in response to high patent activity in China that the U.S. is saying, okay, let's try to get more AI patents, and this is what we've done from a patentability standpoint. But I think that framing from a broader context could be helpful.
Yeah. Cool.
Did you have a question? Or?
Yeah, so again, on this deep learning and kind of the trained method of it, how much of the patent would be dependent on whatever data you put into it to train it? So if you, I mean, you're using images, so if you put in, the Louvre to train it, but then, do you still own that patent if somebody tries to like just trace it with the New York, the Met or something like that instead? Is that the same? I don't know. But like how much of it is depending on that training corpus or the training kind of data that you give it? Because that would,
Okay, good question on that. With so I'm more the training is linked a bit to the data itself. Right? They're linked in the method that it applies to it, but I'm looking more broadly as just the result of the training step and not so much the data. But it's a good thought in terms of when you draft these claims. You're going to tie it into some sort of data itself. I can tie this a bit into, I've got a side startup that I talked to Angie a little bit about that may come in and talk more about in April, but it's in the digital health space. We're using AI for optimizing recipes. And the data itself is actually just text and some images of recipes, but mostly text of the sequence of steps. But the algorithm that is used, what we're using, would work with respect to other data,
right? Except
for certain parameters like how cooking is done. So, but the raw data itself could be other things. So I don't think there isn't that much dependency, and my focus is just on the method itself.
Okay, on the methods. All right, sure. Like the R package that would run it or whatever.
Yeah.
Right.
Questions? All right. Well, I'm going to say hi to Mike, who is going to be on the call. But thank you, and encourage people to go upstairs and our lunch break and that type of stuff, and continue to talk, because I see you taking copious amounts of notes. That's wonderful. And thank you. And of course, I very much look forward to you coming back in April.
Yeah. Thank you for the questions.
Sorry, I should always give you a heads up of who's.
Oh, no, no worries. That makes sense. I'm glad.
So I do some topic modeling, structural.
Yeah, that's what I was meaning in the meeting.
I
I
also do
worked
kind of
really hard to connect.
computer vision content.
So I happen to know he's getting ready to teach
And all of
right
those
now.
are types of.
He teaches at 1:15.
I don't know, machine learning. But only in that last method do you actually give it a corpus to train. But they're all methods, right? I mean, they're all kind of something that somebody could have for a package in R.
I always enjoy.
Only one of them was structured, the other ones were unstructured. So I think it's brilliant. And then there's a bit of like the regression is also because like, are you trying to patent, the Cox model, or are you trying to patent the coefficients off of one data set?
My question is
Right? For me. So, I mean, I think it's an interesting thing. I don't know enough about the patent stuff. Tying it into the disclosure theory is really cool, I think. And the way that kind of advances. Kind of
So this gives me a lot to think about.
I think that's what made it interesting is that because I know nothing, so I'm not grasping that language at all.
Looking at it with the patent economic framework, is what I'm looking at, but the details of catalyst and
what is, I mean, maybe it's too obvious.